Go.
For the dimensional analysis of this problem, I started by breaking the density, gravitational acceleration, and the height into well-known units. So density is known as pounds per foot cubed. Gravitational acceleration is foot per second squared. And then height is in feet. So from there we go into the base units. A pound is a mass. A foot is a length, and that's cubed. Our foot is still a length. Seconds are time, which are squared. And then feet are in length. If you combine all these terms, the lengths cancel to be left with one length on the bottom, and then you have a mass per length times squared. That was the dimensional analysis for 2B. Now I'm going to work on number 3B. So to start with this problem, I found the bulk volume of the core. So the volume of a cylinder is equal to pi r squared times h. You got to be careful because it gives you a diameter in inches. And so I'm going to convert my radius to feet. So I'm going to cut the 6 in half and divide by 12. So my volume is pi 3/12 squared. So that's going to be in feet squared. And then my height is going to be 3 feet. When I evaluate the volume, it equals 0.589 feet cubed. So from there, that's our bulk volume of our rock. And we're given a porosity, so we can find the pore volume of the rock if we multiply the bulk volume times the porosity given. So now we're going to find the volume of the pores is equal to 0.589, that's still feet cubed, times 0.15 for the 15% porosity. That value is 0.08835 feet cubed. So now that we have the pore volume, the problem states that the core sample is fully saturated. So we have 100% saturation in the core. So to get our oil saturation, we do 1 minus 0.25, which is the water saturation, to get 0.75% saturation of oil. Now, within the pore space that's filled with fluid, we have 75% oil saturation. So to get our oil in the core, we multiply the pore volume by 0.75. So now we take this value times 0.75 to get a new value of 0.06626 feet cubed. That could be our answer, except the problem asks for the units to be in barrels. So we convert foot cubed to barrels. 1 barrel is equal to 5.615 feet cubed. So working those units, our final answer is 0.0118 barrels.
For 4B here, we're defining bulk density using porosity, matrix density, fluid density. And so what you see here is you have 1 minus the porosity multiplied times the matrix density plus the porosity times the fluid density. And when you do this all together, you're going to get your bulk density. For C, we're defining density porosity using bulk density, matrix density, and fluid density. Density porosity is just porosity derived from density. And so what we have here is you have bulk density minus your matrix density all over your fluid density minus your matrix density. And when you do that, you're going to get your density porosity.
Okay, so here for problem 6, we have our crossplot of porosity, which is on the x-axis, and resistivity, which is on the y-axis. And as you can see, as porosity increases, there's a slight downward trend in the resistivity. This is likely because as porosity increases, you have more pore space in the rock, and the overall length the current has to travel is probably going to be less, which will decrease your resistivity. Additionally, at the end of problem 6, it asks about temperature and resistivity relations, and as temperature increases, resistivity decreases.
Alright, so for the bonus number 9, water-based muds use a base fluid of fresh water or seawater or brine, while oil-based muds generally have a base fluid that uses oil such as diesel or mineral oil. Both muds can use the same additives, but it depends on the situation. Water-based muds are a lot more common than oil-based muds because they're less expensive, and water has a higher starting density, so there's not as much additives that are needed to reach a desired mud weight. Water-based mud is also easier to clean. It doesn't have as much environmental implication. Sometimes oil-based muds are needed when there's increased downhole temperatures or swelling clays in the borehole. They can also be used when higher levels of lubrication is necessary.